Welcome back, everybody. We're on center of gravity. I love center of gravity. There's all kinds of stupid human tricks you can do. We'll try some in class. In any case, a center of gravity it basically deals with the center of mass. And the center of mass is a point, kind of a point inside an object or even outside an object where all of the mass of that object seems to be centered. So an object, if you throw it, will turn around that center. In any case, that center of mass, if you can imagine it as a point in that object or even outside that object, where all the mass is centered. If the center of mass is above the base, then you can also call it the center of gravity. If the center of gravity is above its base, then you have a stable object. If the center of gravity is outside the base, then it'll topple over. And it's really as simple as that. So let's look at some pictures. If you have three jars, the most stable jar is the one where the base is the widest, and wherever the center of gravity is going to be over the base. So the most stable, this is obvious. You wouldn't even need to have any idea about this to recognize that the most stable here would be A. Now this is actually pretty stable. I would probably least stable. It depends on what you're asking for. If least stable in terms of rolling, this would be the least stable. I wouldn't want this on the shelf like this. But if the narrower the base, the less likely that the center of gravity is over the base, the more likely it's going to topple. So I would say this is the most dangerous in terms of toppling over. This is not going to topple over sideways. It'll roll because it's round, but that's not what they're asking. It's asking about toppling. I would say this is the least stable. And neutral, I guess, in terms of it's the least likely to go either way. I don't even know what neutral means. I'm going to put B. Okay. These are a little easier to see. If the center of gravity, okay, which is, remember, all the mass is kind of over on this side of the truck, and the center of gravity around which it's going to turn. Do you remember a torque is when you have a force that's going to make something turn either counterclockwise or clockwise? If the center of gravity is outside the base, so the base here would be where its wheels are in contact with the ground. The center of gravity here is outside the base. This truck's going to topple over. So truck A is absolutely going to topple over. Why? Well, its center of gravity, let's just put center of gravity. Its center of gravity is outside, or it extends beyond, so it's outside the support base. So therefore it's going to topple. This guy, if you act this straight down, this is not going to topple over, even though that's pretty bad. It's not going to topple over. And this one's even less likely to topple over because as you extend this one straight down, you've got nice support base on both sides. So even though I wouldn't want to park a truck like this, this is not going to fall over. This won't fall over, but this one will. Different kind of question here. Number 3 says both blocks have equal mass. Which one requires more work to tip over? Which one is more stable? If both of these are the same mass, which is least likely to flip over? You just know this from just experience of life. This seems to be more stable. It's lower to the ground, has a lower center of gravity. This one has a higher center of gravity. It's more prone to flipping. So if I were to try to draw this, I don't know if I can draw it or not. Let's say that it's going to flip. Okay, so I've got the block and it's going to be flipping over this way. Do you see, if this is the center of gravity here, I'm going to have to raise it to here. Okay, and if I'm going to do it here, if I do the same thing, if I flip this over, see how good an artist I am. Do you see, I haven't lifted this as high. I've lifted this much higher. And that takes more work to flip. So therefore A is more stable. So A takes more work to flip over. Why? Because its center of gravity center of gravity has to be raised higher, so must be raised higher. And so that's less likely to happen, so therefore, since it's less likely to happen, that's going to be more stable. Okay, what about this pipe? Will it flip over or will it not flip over? How do I tell? Okay, I'm simply going to extend the center of gravity down, and if the base is under it, then it's supported. Okay, so that's actually an easy question. So why or why not will it not flip? It's not going to flip because its center of gravity is over its support base. Lots of people like this chapter. This is easy. Even the concept is easy. What about the bicycle? With the kickstand down, why doesn't it likely to flip over? Well, what is stable? Now we have to simply define what that means. We've never actually thought about it. What does stability mean? Stability means I have got a touching the ground here, a touching the ground here, a touching the ground here. That means that I've got kind of a three-legged stool here. Three-legged stools are pretty good. So all of this is its support base. I've got a three legs. So the support base is here. So if its center of gravity is over top of this triangle, then it's stable. Well, the mass, so some of the mass is sitting down on this ground. The rest of this is located somewhere, I don't even know where it would be, somewhere over top of this triangle. And so therefore, if it's over top, it's stable. It actually stays. That's why you would make a kickstand on a bicycle, so that it doesn't flip, so it doesn't have torque one side or another. So it says sketch in the triangle area bounded by the 3 points. That's what we did here. Where is the center of gravity of the bike with respect to this area? It's somewhere over top of it. Okay. So since it's over top, it will not flip. Okay. So I'll just say it won't flip. Center of gravity is over base. I'm getting lazier with my answers, but that's basically it. Okay. Now for stupid human tricks. If you stand with your back and heels to a slanted wall, you can lean over. Okay. Why can you lean over? You can lean over because your rear end gets in the way. Okay, so if you have the lady and well, she's got a bad back. She's osteoporosis. So here's her head. Okay, so here's her, and she's going to touch her toes. Okay, so where's her toes? I'm so bad at drawing. You're laughing at me probably. Okay, so I don't even know, what do I do? So she's touching her toes. Something like that. See, her center of gravity has to be over her feet. Otherwise she falls over. So her center of gravity can't be out here. Otherwise she'll topple over. So if your center of gravity is here, over your toes, you can do that. But you can't do that when you stand against a straight wall. I'll challenge some of you to do that. You can stand against a straight wall and see if you can touch your toes. It's really funny. We'll laugh at each other. Here's the other one that you can't do. You can, if you're standing with your toes against a wall, you can't stand on your tippy toes. Because what happens is your center of gravity is actually into the wall, and the wall prevents you from doing it. So if this is your center of gravity, if this is where your support is, just on your toes, but your center of gravity is here, you can't do it because you'll fall backwards. So you can't go forward. So I call this stupid human tricks, and we'll do some of these today. There's a lot of these you can do. All right, thank you.